So now take a look at SD-WAN products. So one of the questions that Ali has asked initially about the C-Edge router. So here are the different C-Edge and vEdge routers. So C-Edge is basically all those traditional routers that Cisco has, the ISR, integrated service routers, and ASR, aggregation service routers series that Cisco has. So all these models of different ISR and ASR, they support SD-WAN functionality. There is a piece of software that you can download on these routers and make them SD-WAN aware routers. The regular vEdge routers are vEdge 100, vEdge 1000, 2000, and 5000, and all vEdge routers offer same software functionality. The key difference between these platforms are in respect to throughput, port density, and redundancy in hardware components. Like some hardware has dual power supplies, some has dual fan in it, some has single fan, single power supply, things like that. So these different models offer additional functionalities also. Some offers Wi-Fi, some offers like connectivity to LTE network. So and the Cisco iOS SD-WAN software that supports C-Edge routers, ISR and ASR series, to make them SD-WAN compatible. So that's how you can see that different models of the vEdge routers, they have different form factors. vEdge 100, which is for a small office environment. And then you have 1000, which supports the bandwidth of 1 gig. The 100, it supports only 100 MB. And then you have model 5000 and 2000, which support 10 gig and above. You can use the 2000 or 5000 in large data center environment. You can use vEdge 100 in branch offices. And then if you have a very small office where only few users are sitting, you can use vEdge 100. And then you also have an option of going with vEdge Cloud. So that's how the SOHO means a small office or home office, then branch, head-end aggregation, then higher capacities, 20 gig plus, and then the virtual vEdge. This is the vEdge platform. So Viptela components deployment. The controllers deployment, there are different options how you can deploy these controllers. So one of the option is to get all your controllers in the Viptela cloud that we have done. We ordered all the Viptela component in the Viptela cloud, and these are basically created by Cisco or Viptela, and we don't have to do anything. We just get our controllers directly from Cisco, and once you order your vEdge router, it's already pointing to your controller devices. Then you can also get these devices through MSP Cloud, which is managed service provider like Verizon or anyone else, or a cloud service provider. Or you can also deploy them on premises in your own data center. You can have them on an ESXi server. You can create VMs for each device and then download the software and deploy them. So there are 3 different options to deploy the controllers. On-prem or the service provider hosted, you can do it either ESXi or KVM, or the cloud hosted, you can do it either on AWS or Azure. Now, the vEdge deployment options. So vEdge deployment options are, so there are 2 types of vEdge. One is the vEdge appliance, which is the hardware, and one is the vEdge cloud. So for the hardware one, you just connect the AC power, you connect LAN and WAN interfaces. It automatically goes through with the ZTP process as we have seen earlier. And in the vManage, we just click on Send to Controller option to send vEdge list to the controllers, and then you're pretty much done. For vEdge Cloud, you have to create vEdge Cloud VM instance on the ESXi or KVM or on the cloud AWS or Azure, and then you upload. You basically create a Excel worksheet where you put all your device serial numbers and then upload the device serial number to the controllers, and then you have to install the signed certificate on the vEdge Cloud routers. And the below screen you see that this is from the vManage, and once all your vEdge Cloud comes up, you see their serial number and the token number. This token number we will discuss in the next slide, what exactly is the token number. And then it shows you the host name of these routers, IP addresses, and then in the last column it shows you whether these are valid or invalid. So if they are authenticated and they are the valid devices, you will see a green valid sign on the right of the screen. So with Della, these vEdge routers, they use a certificate-based trust. So all elements of SD-WAN fabric authenticate each other using a whitelist model. And whitelist model is basically it uses a certificate to authenticate. The certificate serial number is used as a unique identification for each device. So in the screen you see vBond, vManage, vSmart, and all have a certificate serial number. So when vEdge appliance comes up on the network, so one thing which is unique about the Viptela vEdge router is that it has a TPM chip on the router, which is TPM means tamper-proof module. So tamper-proof module, it's a chip that is basically installed on the router during the manufacturing process, and it has a certificate stored in that chip. So each physical vEdge router is uniquely identified by the chassis ID and certificate serial number, and this serial number and certificate serial number is already there on board on the TPM, which is installed during the manufacturing process, so nobody can tamper it. Certificate, and this during the manufacturing, certificate is signed by AVNet, and then once you bring up the router, it's also the semantic chain of trust is used to validate the control plane. Alternatively, you can, if you don't want to go to semantic, or you can have your own root certificate authority and chain of trust, you can validate your devices within your own organization. So if you see the right-hand side, the picture is showing you the TPM chip, which is signed by AVNet, and then it's also semantic trust signature on this device, which is in the Viptela software, and the TPM AVNet signature is in the hardware. vEdge Cloud is it uses the OTP/token process. OTP means one-time password. So it creates one-time password and a token generated by vManage. vManage generates a token for each vEdge Cloud router. Is based on, so they also assign a chassis ID and serial number to the cloud router. Although they are software entities, but they assign a chassis ID and serial number to each vCloud router also. We can upload them through a spreadsheet in the controller list, and then this OTP token is supplied to vEdge Cloud in the cloud initialization process during the VM deployment. This is one-time password is one kind of security. So vManage issues self-signed certificate for the vEdge Cloud. After the OTP token validation, it removes the one-time password to prevent any reuse of that password. So that password is only one time. You have to give that password during the VM build process, and then after that, that password is not usable anymore. And semantic root chain of trust is also used to validate the control plane element. Um, Alternatively, you can also, same way as you can do in the hardware vEdge, you can also do the self-signing of these certificates through your own enterprise roots certificate. So, in the conclusion,
is there any difference in the mechanisms in these two security mechanisms for the vEdge and the actual physical, and what's vEdge?
the only difference is that in the hardware type vEdge, the security is in the hardware chip, which is installed on the router during manufacturing process, and the same type of security is provided on the vEdge cloud in the software. So that functionality which is in the hardware in the vEdge appliance, you get that thing in the software. So finally, we can say that Viptela SD-WAN solution can be deployed in conjunction with the existing MPLS. As we have seen in one of the slides that a branch office had 2 MPLS connections, and we have dropped one of the connection, and we have ordered a broadband connection from that branch office. So this way we can use both solutions from a branch office, but we can save cost by dropping one of the circuit. So what we can do, all those bandwidth hungry applications, we can carry them over the SD-WAN overlay to save cost with MPLS, and and your other type of traffic, which is real-time traffic that needs certain number of SLAs, and if it has any compliance issues, then you can traverse that data on your MPLS circuit. The rest of the applications, you can move them to the SD-WAN solution. Hybrid approach to supplement MPLS with SD-WAN is recommended. So the companies are not ready to completely remove their dependency on the MPLS. And I have read somewhere then that according to a survey, 78% of the organization deploying SD-WAN have no plan to completely drop MPLS from their WAN. So they want to keep MPLS. So this hybrid approach is the better approach to keep both solutions together. And hundreds of enterprises, starting from tiny startups to global corporations, have already started their SD-WAN journey and getting benefits of the new technologies. So this is the conclusion of today's session.